Hi guys, good morning everyone. Welcome back to my channel. My name is Sai Kiran. Today we are going to discuss about AWS ECS, which is Elastic Container Service, and then we are going to discuss about AWS ECR, which is Elastic Container Registry. Guys, let's try to understand the difference between server and then the difference between virtual machines and then the difference between containers. So when virtual machines and containers were not in the game, we'll see what kind of strategies does organizations do follow. Guys, please watch this carefully because this is very important topic. Like at least try to listen the first intro part. So let me explain you what kind of strategies does organizations do follow when cloud and the virtualization was not in the game. They used to purchase a NAS devices. NAS device is again nothing but network attached storage. Like these are nothing but also called as servers. We do have a very good providers previously, Dell EMC or Hitachi, right, or HP, some other companies. So for individual web application or for individual web server, they used to purchase one single server, and for the database also they used to purchase one new NAS device just for the database. Let's forget about the virtualization and containerization, cloud and all these things. And then they used to purchase another server for email or for any communications or for Teams or communication, whatever it is. They used to purchase another NAS device. Imagine just for one application, if it's Python based application, they're purchasing three devices. Imagine if they wanted to build another application which is Java based application. Again, they used to buy three new devices for web application, for web server, and then for database server, and then for the communication like email and all those servers. If you go and watch in the data centers, if you go and watch in the data centers, you will be seeing a hell lot of racks, storage racks, right? All these contains these web servers, database servers, and the NAS devices. Again, the additional cost was to take the backup of these devices, right? Again, the additional cost was to take the backup of these devices. Imagine after 5 to 10 years, after some at some point of time, the management overhead will be huge because they will be containing a lot of physical devices at one point. Also, the major disadvantage here in the physical servers is it will be dedicated only for one single application. The entire server will be dedicated only for the one single Java application or one single Python application or one single .NET application. Again, it's a waste of a storage, right? So here comes the engineers came with a technology called virtualization. There is something called virtualization, right? Here in virtualization, watch carefully guys, this is quite important. we do have something called we do have something called infrastructure. Who is maintaining this infrastructure? Example, you can also say this as data center. Example, AWS or Azure or GCP, whoever it is. On top of it, we do have something called hypervisor. Hypervisor. What are the different type of hypervisors we do have? For Microsoft, we do have Hyper-V, and then for Citrix, we do have Zen Server, and then for VMware, we do have ESXi. Don't stress yourself on the server names, I'm just giving you a small heads up, that's it. So before, they used to purchase individual servers for individual application, right, for database, for web servers, and for the communication. But here, if you watch carefully, in virtualization we do have separate guest operating system. Let's say this is Ubuntu, and then here also we do have separate guest operating system. Guest OS, this is, imagine this is Windows operating system, and here this is again a separate guest operating system with Linux environment. If you wanted to install Jenkins app here, you need one library, right? What library it is? Before installing Jenkins, we will installing Java, correct? And then here, if you wanted to develop or if you wanted to deploy on this guest operating system a node application, a node application, again, what library you required node 14. Or here, if you wanted to deploy any Django or Python application, not Python, Flask, then what libraries you required Python libraries, correct? Now you might be getting a doubt, Sai, what is the point of deploying three applications in three different servers? Why don't we deploy it on single guest operating system? See guys, what will happen is, if there is a single guest operating system here, and if you deploy three applications here, imagine due to some disaster or some physical damage occurs, and this server is completely down. In such case, what will happen? All your three applications will be down. So it is not a best practice to deploy all the three applications in the same guest operating system. So again, I'm going to tell you something here. Now watch carefully guys. This hypervisor, what exactly it will do is, first I'm going to tell you a small example. Don't take me in a funny way. Imagine there are three cousins. Imagine there are three cousins, and you want some money. You want some money, not now, during the time of your pursuing like btech or mtech, and you wanted to ask money for your father. But instead, what you will do, you will send a request to your mom. And what your mom will do, your mom will make sure that she is taking money from the dad, and then she will make sure that she is providing enough resource to all three cousins, correct? That's the job of mom here. Here, the reason why hypervisor is called as a core component here, because it will take the necessary requirements from the host, from the infrastructure, and it will make sure that it is providing all the resources to the guest operating system. It will make sure that it is taking the enough resources from the infrastructure, and it will make sure that it is providing all the resources to the guest operating system. What kind of resources it required? CPU, RAM, GPU, or hard disk, etc. So hypervisor will make sure that it is providing all the required resources to the guest operating system. But here the major advantage here is, guys, watch carefully. Each guest operating system will consume a lot of resources from the infrastructure, and this application will also looks heavy during the time of spinning, or during the time of reboot, or during the time of starting, correct? The reason is, individual guest operating system is containing individual application. And also, if anyone doesn't understand this pattern, I'll tell you a very simple example. Try to understand it, guys. You are creating one ec2 instance, right? You are creating one ec2 instance. Under ec2 instances, you are selecting security groups, you are selecting which volume you want, gp2 or gp3, and then you are selecting subnets, and then you're giving the name, and then the major thing is you are selecting the operating system. From where you are selecting all this? From the data center. Like it will not be visible for you, but in the backend, this is the exact thing which happens, correct? So just understand the same thing here. This is your application. On top of ec2, what you're going to do, you're going to install Jenkins, or if you wanted to install any sonar cube application or ansible or something, then you're going to install on top of this ec2, correct? Here this guest operating system is ec2. So as I said before, the major disadvantage here in the virtualization is it will consume hell lot of resource from the infrastructure. Imagine a developer is working on some Python application or something on the guest operating system one, right? And he developed each and everything. We'll be having some different environments in real time, like dev environment and testing environment, and staging, and then QA or UAT, and then we do have prod. So once developer done his part on this guest operating system, everything will be works fine in his environment. But when the test engineers try to test this application, it will not work. The reason is, developer will be again coming back and saying it is working in my environment, and the tester will be saying, see, you have given the application, but it's not working in my environment. There it will starts the mud fight, right? So to avoid all these To avoid all this, they came up with an technology called containerization or containers. So let me explain you the containers again. Watch carefully. Here, just like virtualization, we do have infrastructure. Again, it's an AWS or Azure or GCP, whatever it is. And then on top of it, we do have operating system. On top of it, we do have operating system, right? On top of it, we do have container engine. Sorry for my drawing, guys. Just hold on. On top of it, we do have container engine. Container engine. What were the different type of container engines we do have? Docker, container D, and then Creo. Right, these are the different types of container engines. If you watch here, let's remember our previous explanation, which was servers. Previously, when VMware when virtualization and containerization was not in the game, they used to purchase servers, and then VM came into the game, and what they did, they have allocated individual guest operating systems, and hypervisor, what it will do, it will provide resources to the guest operating systems. But here there will be no guest operating systems. Instead, we'll be having containers. Instead, we'll be having containers. Container 1, container 2, and then container 3. So, in containers, what it will do is it will take the required dependencies from the host operating system. So here in containers, I told you one mud fight, right? In virtualization, in containers, the application will be packaged with all the files and configurations, right? With all file configurations and dependencies, whatever it is necessary for it to run in any computing environment without having to add anything else to. So we will be avoiding such issues, right? In containerizations. I hope you understand, guys. If you do not understand, please put it in the comment section, or if you hesitate to keep comments, you can ping me on LinkedIn and ask me the doubts, because this is quite important. After completing the AWS, we are going to discuss about Docker and Kubernetes. So I believe if you understand here, then it would be easy there to grasp the information or practicals. So now let's jump on to our EC2 and ECS, which is Elastic Container Repository. Right, guys, do not stress yourself more on this ECR. I'll tell you very simple example. There are some source code management tools like GitHub, right? And then we do have Bitbucket, right? There are some XYZ tools. All these tools comes under source code management tool itself only. What we are going to do here, we are going to store our code here, right? Once you're working in the organization, we'll be having some Docker pre-built images. So you're going to store this in a Docker's private registry. Docker's private registry. And another example I want to tell you, there is some tool called Nexus. There is a tool called Nexus, and then JFrog. So these are artifact repository tools. Artifacts will be stored here, like var file or zar file or year file. If you remember our day 29 class, I told you something where the AWS market is capturing the users. When you are using AWS infrastructure, when you are building an image on AWS EC2 instance, then what is the point of storing in a Docker private registry again? End of the day, Docker, this Nexus, JFrog, GitHub, Bitbucket, all these comes under third party tools for AWS. Correct. So that is the reason why they came up with something called Elastic Container Repository, where it allows us to store, manage, and deploy containers, images, and then artifacts for your application, for your application. Now you understand, right, what exactly is ECR. So it is just like a repository where you're going to store all your files. So it will be easy for you to integrate or authenticate when you're working on EKS or when you're working on ECS. So now let's discuss about ECS, which is Elastic Container Service. Elastic Container Service, which is also called as ECS. See, Elastic Container Service is fully managed service for running Docker containers on AWS. It simplifies the deployment process and it simplifies the management process, and it will also make sure that the scaling of an containerized application. When you're creating this, when you're configuring like creating the cluster of this ECS, there will be something called auto scaling groups. This will be configured automatically where it takes care of the scalability. For example, I'll tell you in Docker we do have something called Docker Swarm. In Docker we do have something called Docker Swarm. What it will do, it will make sure that it like you can easily launch and maintain your application without worrying about the underlying infrastructure. As I said before, again, Docker Swarm is a third party tool for the AWS. So they wanted to capture the market, they wanted to let the users stay with their services itself only, and they came up with a service called Elastic Container Service. So on a high level, Elastic Container Service is fully managed service for running Docker containers on AWS. It also simplifies the deployment process, management process, and it also take care of the scaling of our containerized application. So when we like people who are not understanding this, don't worry. We are going to do a small project on ECR, and then we are going to do a small project on ECS. So now you will be understanding clearly. So let's go and do some practicals on it. So here is my console, guys. Before coming to the session, I have installed one EC2 instance, which is T2 Micro Ubuntu. Once after the installation, make sure that you're attaching an IAM role. Make sure that you're attaching an IAM role, guys, and also make sure that you are installing AWS CLI, right? So two things you have to do. The very first one is creating EC2 instance and make sure that you're installing AWS CLI. Close it. Now open IAM roles. I do have one role already. I'll show you what kind of policies you are supposed to attach to our IAM role. So these are the two policies you are supposed to attach to your IAM role. Okay, these are the two policies. Once you have created the IAM role, make sure that you're attaching that IAM role to your EC2 instance. Modify, refresh, scroll down, and then attach it. And also log into your log into your instance. I'll tell you the easiest way to install the Docker, right? See here, get.docker.com. Copy this, come back here, curl, paste the link here, pipeline, and then bash. It will take some time to complete. Meanwhile, what you can do is create one ECS cluster. Will take 5 to 10 minutes. So let's create it now itself only. Elastic Container Registry, and then Elastic Container Service. Open registry, create registry, give the name ECS ECR repo, and simply click on create. It's a private only, right? Yeah, private only. Simply click on create. Throw it back, and then open ECS, create cluster, give the name as ECS testing, scroll down, don't select AWS Fargate. Fargate is again a serverless architecture. For now, select EC2 instance only. Tomorrow we are going to do a small project on AWS Fargate, right? So see auto scaling groups, I told you, right? Auto scaling groups, and then on demand, Linux 2 is fine, T2 Micro is fine. Scroll down, make sure that you're selecting a create new role. It will automatically create one role. Maximum instances, I want two. And then, minimum instances, I want two, and the maximum, I want five, just for high availability. Make sure that you're selecting a proper SSH key. I'm going to give 30 GB. 30 GB is the base. 30 GB is enough for us. Scroll down and then make sure that you're selecting appropriate VPCs. I'm going to clear the selection. I'm going to select only public instances. Public subnets. Existing security group I do have already, which was public management group. Scroll down, auto assign, turn on, and then simply click on create. Let's leave it for some time, guys. It will take for some time to create. Meanwhile, you can log into your instance. Docker has been installed successfully. Just check whether if it is installed or not. Nice. So now we are not going to deep dive into Docker, guys, but I'll make sure that you understand how to deploy the container, what are the basic, some of the basic Docker commands, and we'll also log in inside to the container and we'll do some modifications and we'll see how it behaves. At last, we are going to push our I do have one GitHub repository. We are going, it's an like web server, a normal web server where we have used for auto scaling groups, and I'll make sure that the entire application is containerized. I'm going to show you how to containerize an application, and then we are going to push that container, push that Docker image into our elastic container registry, not to the Docker hub, right? So now let's run a Docker command. Docker run -d. I'll tell you about the entire command, don't worry. -name, I'm going to give the name as Nginx 01 -publish. I'm going to publish it to 8000 to 80 port, and then image, this is the image, Nginx latest, right? So what exactly is this command saying is docker run -detach. -detach mode means if I'm not entering -detach mode, what will happen is this Docker container will be running in this tunnel itself only. If I enter control C, then what will happen, the container will be stopped again. So for that reasons I am giving -detach mode, and then -name. What was the name I wanted to give? I want to give my container name as Nginx. I have entered the wrong spelling. Nginx 01 -p means either it is port forwarding or publish. We are publishing it to run on 8000. Here what we are doing is docker, if I access my public IP under 8000 port, I supposed to get Nginx. Before, what we used to follow, we used to create one EC2 instance and then we used to run some 4 or 5 commands, and then sometimes Nginx might gonna run and sometimes Nginx might gonna corrupt. And even if you access it with the public IP, sometimes it will load slow and we'll see some latencies. But now you will see how it behaves. But now we'll see how it runs. Enter. Unknown flag. What it is? Unknown. Docker run -d hyphen name. I think, yeah. Hyphen name. Nginx hyphen port. Enter. See, it is saying unable to find the Nginx image locally. Pulling from library. Where is this library? Let's see where is this library. See, this is my Docker hub. These are my existing images. I have built it 2 years back, 1 year, 10 months, 7 months. So the image is downloading from the image. See, from here the image is downloading. If you want Jenkins, no need of installing Jenkins. You can simply take Jenkins image from the Docker hub. We are in our environment, we are running on the same images itself only. We are working on, like, we are using master and worker architecture. This was signed out, I don't know why. If you watch here carefully, Kiran 2361993, this Kiran 2361993 is my registry, right? And then this testing means it's an container repository. It's not an container registry. It's my container repository. And if I click on tags, see, these are my images. Latest app worker image, latest app vote, it is also an image, latest app results, it is also an image. Now you understand, correct? If I come back here, see, our Nginx image has been successfully deployed. Now let's see whether if it has been deployed or not. Docker ps. See, our container is running on 8000 port. Let's go and access it and see whether if it is really able to access it or not. Control V, 8000. See, I can able to see my Nginx here. Now let's do some changes. Let's log into the Nginx container and we'll change this name. Let's log in. Docker exec -it. What was my container name? Nginx 01, Nginx 01, and then bash. See, I have successfully logged into my container. Guys, I made an mistake here while entering the name. You make sure that you are entering it properly, right? I successfully logged into my Nginx. Now I'll go to the default directory of the Nginx, cd user share Nginx, and then HTML. Nano is not installed here. Apt get update. Let's install the nano also. Apt get install nano -y. By default, no packages will be installed inside the containers, right? ls-al. So this is our index.html file, nano index.html. Let's change this. Welcome to mastering cloud by Sai Kiran Pinpatruni. Control X and then Y, enter. Save it. Okay. Now if you go back and refresh here, see I can able to see my welcome to mastering cloud by Sai Kiran Pinpatruni. Got it? Now you understand, right? I'll show you how this logs runs. Docker log. What was my container name? Okay, I have to get out first. First I have to exit, and then now Docker logs -f. What was my container name? Nginx 01. See here the logs are capturing. Now I'll go here and I'll do refresh continuously. What will happen here? See, it's accessing from my public IP 49.37.155.24. Now what we are going to do is we are going to go to our container registry. No, not container registry. First we are going to build one image, and then we are going to push it to our registry, and from ECS, from next time these logs will be stored in our CloudWatch logs. We'll see step by step how it works, right? Control C, go back to your GitHub repository and clone the repository. I'll pin this in our description. You can go and access it. Copy the repository, come back to your EC2 instance, git clone, enter. Is it pasted? No. Enter. cd ECR. I'm going to remove some files which were not required. rm-rf. Jenkins file is not required. App file is not required. Error file is not required. And then k8s deploy not required. Nginx default not required. ls-al. Okay. Docker file index.html. Also remove .git. Right. Now what I'm going to do is, if you remember, we have used the same files during the time of auto scaling groups. Now I'm going to containerize this application. These three files, I'm going to containerize it. How? I'll show you. Nano docker.file. See here what we are doing is we are telling Docker to take the Nginx latest image from Nginx latest image. Previously this is maintainer, maintainer, now it is label. It's fine, no problem. It's just my email. Run apt install. We are installing curl, we are installing some netstat tools, and then we are installing ZQ. Let me add one more line here. Run apt update. And then we are copying this index.html file. Just now we have seen one index.html file, right, in our current directory. I am copying it to user share nginx html. Why I am copying? Because nginx default directory is this. People who are not understanding this, don't worry, I'll tell you in a very simple way. If I copy my index.html file here, next time when I try to access, where is this nginx? Next time when I try to access my IP with the port number, here I should be able to get my web server, not this nginx server. So that is the reason why I am pasting all these files in this location. Got it? And then scorekeeper.js, again I'm pasting in HTML itself only, default directories. Style.css, I'll remove this copy.error file is not required. Control K, and then with the help of cmd parameter I'm running nginx. Nice. Control X and then Y. Now you have to build this image. In order to build this image, we have one command. I'm going to show you what command is that. Select your ECR-ECS repo which was in elastic container registry, and make sure that you're selecting view push commands, right? So once that part is done, make sure that you're making an authentication between your ECR and then your instance, because the reason why we have attached that ECR full access role is for this authentication purpose only. Go back to your EC2 instance. First run this, enter. But what you'll do in the Docker, you're going to enter the Docker credentials there when you're working on the Docker. I mean, when you're building an Docker image in the CLI, you are supposed to enter the Docker credentials. Here we are simply entering a command for the authentication between your ECR and then EC2. Right, it's successfully logged in. Now I'm going to run the build command. Docker build what? Build a file hyphen t ECR hyphen ECS hyphen repo. This is my repository name, and then dot. This dot represents, what this dot represents is, in the current location it will go and search for the Docker file. You are supposed to run this command where your Docker file locates, right? You are not supposed to enter it somewhere. Come back to your EC2 instance and make sure you are pasting this. Enter. Docker image has been successfully built. Now come back to your ECR registry again. Make sure that you're tagging it with your ECR. Copy it and then paste it here. See, it has been successfully tagged. If I enter Docker images, see, I can able to see my image along with the ECR-ECS repo tag. Come back here. Now let's push it. Let's push it to our Elastic Container Registry. See, the image is pushing to our Elastic Container Registry. Okay, the image has been successfully pushed. Now here comes the major task. Go to your cluster. Our cluster is deployed and up and running, right? Now make sure that you're selecting task definitions, right? Make sure that you're selecting task definitions and select create new task definitions and select create new task definitions with JSON. Guys, watch here very carefully. Open a new tab and enter AWS ECS, AWS ECS Nginx task definition. You will be getting one YAML manifest here. If you scroll down under directories, you will be watching one Nginx. Select it and make sure that you're selecting nginx.ec2json. Copy the entire thing and paste it in our local Visual Studio Code. Give the name. I'm going to give the name as ECR-ECS. Enough. I'm going to I do have my own image. Just now we have copied our image to the registry, right? If you come here and if you refresh, I can able to see my latest image. I'll copy the URI here and I'm going to paste it here. Paste it, scroll down. Again guys, I'm not deep diving into Docker for now. This is just an ECR and ECS session. So when we're learning about the containers part, then I'm going to explain each and everything very clearly. Right, so again, when it comes to the log configuration, yes, we need AWS logs. Copy this log group name, go to the CloudWatch and make sure that you are creating a log group name with the same name. Log groups, create log groups, paste the name here. Make sure the retention for 1 day. After 1 day it will gonna delete automatically. Create. Right, now come back to your ECS again, I mean your code. Make sure that you're changing it to ES1. Copy this name again and paste the same with the family name. Right, copy the entire part, Control C. Come back to your ECS, remove all these and then paste it. Simply click on create. So once this has been created successfully, make sure that you're selecting deploy and run task. Here, when you're running the task, make sure that you're selecting the existing cluster. We do already have the existing cluster, so I'm leaving it for ECS testing, right? And then select launch type. Make sure that you're selecting EC2 here. Task, scroll down, desired instances. I want 2 instances. Task group name, I'm going to give ECR and ECS. Simply click on create task. Once you have created, if you refresh, scroll down and if you refresh here, this pending state should show running. Refresh, it's running successfully. Now here previously we do have something called, if you go inside the container under network, we do have something called public IP address. If we click on it, then we can directly able to access our containers, but I don't know why they have removed now. We have to create one load balancer to it, right? We have to create one load balancer, that is something called here service load balancers. I'll keep aside. First, let's configure this. Task configurations, task definition, task clusters, EC2 testing. Scroll down. Here are our tasks. Now you are supposed to create a service. Create service, launch type. Make sure that you're selecting EC2. Scroll down, select service. We already do have ECR service. If you remember, before we have given ECR service name, right? And the revision is one itself only. If you are doing any changes to the container and if you are storing it, then that will be the revision 2. And if you're doing any changes, that will be the revision 3. If you remember, yesterday we did one video which is elastic beanstalk, where we have stored version 1 and version 2, just like that. Here revision 1 and revision 2, but we didn't do any changes. So for now I do only have revision 1, so I am selecting revision 1. Service name, give ECR service. And here comes the important thing, replica set, I mean replicas, and then daemon sets. Replica set is again, it is asking how many replicas you want. I want 3. Replica set is again nothing but it will create 3 containers. And then daemon set. Daemon set is something, this will come during the time of Kubernetes, when we are working on deployments. We do have daemon sets and stateful sets. What this daemon set will do is, for example, if there are 3 instances running, for example, if there are 3 instances running, 1 2 3, and it will make sure, daemon set will make sure that each container is going and deploying in each instance. But in Kubernetes, it will make sure that each container is deployed on each node at any cost. This will be more useful during the time of Prometheus monitoring. I'll tell you again when that comes. Okay, just for understanding, try to understand this. And then now we are going to select replicas. How many replicas I want? I want 3 replicas. 3 containers will be created. And then what were the deployment strategies? I want a rolling update only. And max running task is 100, minimum running task is 100, yes, and maximum running task is 200%. Okay, scroll down, deployment failure, no, this is not required. And here comes the major thing, which is load balancer. Select application load balancer. 8080, we do not have any load balancer. Now let's create one load balancer. Application load balancer, give the name ECR hyphen ECS. Scroll down, internet facing. I'm going to select my VPC. Select, no, Kubernetes VPC, yeah. Select public subnets, don't select private subnets here. I do have my own security groups. Come back here, I'm going to enter 8000. This is my port number. I do not have any target groups. Let me create one target group. In target groups, I don't want to give any, like, I'm not going to attach any instances. Simply, I'll just create the target group. That's it. I'm not going to attach any instance. Create target groups. Okay, all good. Close the target groups. Come back here and refresh. You will be seeing your ECR target groups. Scroll down and then simply click on create load balancer. Nice. So once this part is done, open your Route 53 and let's attach our application load balancer DNS to our Route 53. cloudvishwakarma.in, create records, simple routing, click on next, define simple record. Guys, I'm doing it bit fast. People who haven't watched my Route 53 videos, please do watch so that you will be understanding it very clearly. Traffics to IPv4, check endpoint, application load balancer, region, I'll mention US East, yeah, North Virginia, and here is my load balancer. Define simple record. Okay, it will take 1 minute time to create. Let it create. So now come back to your ECS. Now come back to your ECS, and you will be able to see the load balancer here. Select it. Health checks, leave it as it is. Okay, here I'm giving 80 as the port, right? 8000 is to 80. Target groups. Okay, it is creating already. Nice. Come down and then create. Let's wait for some time, guys. It will take few minutes to come up. You can able to see here, if I refresh, you'll be seeing 3 replica sets here. You'll be seeing 3 replica sets here because we have given 3 replica sets, right? It is still deploying. Let's wait for some time. It's still deploying. Just go back. Yeah, I got my replica sets here. See, before I have created only 2 instances, now it was 3, total 5. Refresh, everything was running awesome. Come back to your service has been created or not. Okay, service has also been created. If I go here, deployment is still in progress. It might take few minutes. Okay, let it take, no problem. I'll close the unnecessary tabs. I'll close the GitHub tab, close it. Instance tab we required. Okay, let's wait for it to come up. Once this has been came up, then we can able to access our container with our domain name. What was the domain name? cloudvishwakarma.in. Okay, it's accessible. If you see here, see the application which what we clone from the GitHub repository. I'll open this again. This application we have cloned, right? This one, the same application we have used for auto scaling groups. If you remember, index.html, here the files are separate. Scorekeeper.js, stylesheet.js. We have containerized all these application into an image. Where is our image? Here is our image. Now you understand, right? See, if I refresh, it's a color game. Got it? So this is what I wanted to explain you guys. Tomorrow we are going to meet up in another session with the serverless architecture, which is Fargate. So guys, if you're watching this, I request you to please do practice. Even if you are not liking or not subscribing, it's totally fine. I can understand, but please try to do the practicals. Else, you'll face a hell lot of issues during the time of interview. Nowadays, everyone is asking. I'm saying it again and again. Please don't take me in the wrong way. Nowadays, everyone is asking all real-time practice scenario questions itself only. Even if you don't have the DevOps experience, even if you don't have the Kubernetes or containers experience, it's totally fine. If you do practice, at least you can able to crack the interview. Once you go inside, the functionality and the tool functionality, everything is same, but the way of approach is different. They will be training you, they will be giving you KT sessions like that. So at least, even if they're giving the KT sessions, you should be in a place where to understand what they are saying, right? So in order to achieve that first, you have to do the practicals properly now. Got it? Thank you so much everyone, and we'll see you in the tomorrow's session. Have a nice day. Bye bye.